So let's turn our attention to the different ways, at the moment anyways, that we can solve a linear system. And it turns out to solve a linear system, especially if it's 2 by 2 or even 3 by 3, one of the ways that we can solve them is by graphing. In 2 by 2 systems, we end up with lines, and in 3 by 3, we end up with flat planes and surfaces. But we have actually graphed 2 by 2. We've graphed these before, so we can use that to our advantage. Because again, what's a graph? A graph consists of all the ordered pairs that solve this one. This graph consists of all the ordered pairs that solve this one. So what I'm basically looking for is, when do those two graphs intersect? Where they intersect is the solution. If they don't intersect, there's no solution. All right, so they're parallel or something like that. So there's a nice visual technique we can use, and then these two are algebraic. And what I'm going to do is just show you them in action, and then later on what we'll do is I'll do some groundwork explaining in more detail what's happening behind each one. All right, but right now this is like some groundwork on the methods we use. Of course, there are more methods as we go deeper into the chapter, but for now these are the big three. All right, we can graph them, we can use a substitution technique, or we can use elimination technique. So graphing, well, what I need to do is graph this equation. And probably the easiest way to do that is to rewrite it in a nice y equals mx plus b form. So this one starts at 0, 3, and it has a slope of -1, which is -1/1. So this graph is starting at 0, 3, and then going down 1 and over 1, down 1 and over 1, down 1 and over 1, up 1 and over 1. All right, so here is the graph, all right, of x plus y equals 3. Again, those are all the ordered pairs that solve that equation, right? They're all solutions to that equation. But what about the next one? Well, we got to graph it. So again, moving some things around, subtracting 2x, we get -y equals -2x minus 6. Dividing everybody by -1, we get y equals 2x plus 6. So my y-intercept is at 0, 6, and my slope is 2 over 1. So I'm going to come to 0, 6, right? And then my slope is 2 up and over 1, or 2 down and over 1. And we can already see the solution. So there, right, is the graph of 2x minus y equals -6. So I have all the solution points for x plus y equals 3. I have all the solution points for 2x minus 1 equals -6, and I can see that there actually is one solution point that's common to both. That's your solution, and it looks like that's occurring at -1, 4. Easy to check, right? -1 plus 4, that equals 3, right? 2 times -1 minus 4. Well, that's -2 minus 4, which is -6. So it works. So there's one way to solve a system of equations, and that is to use a graph, right? Basically a nice review of what it meant to solve linear equations in the first place, right? Or excuse me, to graph linear equations. So good review, especially for some of you moving on and going to be taking a final here soon. All right, so let's go ahead and we'll stop there at a moment. All right, and what I'll do is come back to you nice, fresh, and clean, and I'll show you the substitution and then the elimination later. But I'm going to do those in their own videos.